Now that we know the derivatives of trigonometric functions, we need to be able to apply that knowledge in conjunction with other rules of derivatives in more complex problems. Let's practice a few examples. Example 1. Find the derivative of x cubed tangent x. I hope it's clear to you that we need to use the product rule for this example. So we'll take the derivative of the first function times the second, plus the first times the derivative of the second, to come up with 3x squared tangent x plus x cubed times the derivative of tangent, which we learned is secant squared x. Moving on. Example 2. Find the derivative of this function, 2 sine x minus 5 cosine x plus 8 secant x. Now here we use a couple basic properties of derivatives I want you to remember. That the derivative operation splits up over plus and minus signs, and that constants when multiplied can pull out in front of the derivative. So I might even like to rewrite this function as follows: 2 times the derivative of sine x minus 5 times the derivative of cosine x plus 8 times the derivative of secant x. Now, it might not be necessary to write that step, but for me it's helpful to break the big problem down into smaller pieces. Okay, now applying the derivative to those individual trig functions, we come up with 2 cosine x minus 5 times a negative sine x plus 8 times the derivative of the secant function is secant x tangent x. Next, find the derivative of f of t equals cotangent t divided by t squared plus 1 on the interval from 0 to pi. Let's combine the quotient rule with what we know about trig functions. So f prime of t equals low d high minus high d low over low low. So low d high, the derivative of cotangent is minus cosecant squared of t, low d high minus high d low. The derivative of the denominator is just 2t, remember derivative of a constant is 0, divided by the bottom squared. And let's leave that expression for f prime. Finally, find the slope of the line tangent to the graph f of x equals cotangent x at the point x equals pi over 4. Recall that the value of the derivative tells you the slope of the tangent line. So this question is asking us to first compute the derivative, and second, evaluate at the number pi over 4. As we saw previously, f prime of x is minus cosecant squared x, or if you prefer, minus 1 over sine of x squared. Plugging in pi over 4, and recalling our trig facts, that the sine of pi over 4 is square root 2 over 2, allows us to compute the slope. Minus 1 over root 2 over 2 squared. That simplifies to a slope of negative 2.